Hi, welcome to the section 4-6 notes. This is on congruence of right triangles or hypotenuse leg. Sometimes you'll see it written as HL for hypotenuse leg, and sometimes you will see that written as RHL. So I just want you to be familiar with that. They mean the same thing. One just means hypotenuse leg, and the other is right hypotenuse leg. But again, they're just talking about the same thing. So first up is a hypotenuse in a right triangle, the side opposite the right angle. And it is the longest side in the triangle, and the right angle always points to the hypotenuse, which you can see over here. So hypotenuse is always across the right angle. The legs are the other two sides in a right triangle. So if you look here at this theorem for hypotenuse leg, it says if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. And you can see in the picture here in terms of what's congruent, and you might think back that we talked about the 4 different ways that we've proven triangles are congruent, the shortcuts. If you remember, we've talked about side, 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 angle, side, angle, and angle, angle, side. And then we talked about a few others, and we said that, we've got a lot of A's and a lot of S's here. And we said previously that ASS, our bad word one, is not a way to prove triangles congruent. We said our bad words backwards is not a way to prove triangles congruent. And we also said that angle, angle, angle is not a way to prove triangles congruent. That's a way to prove they're similar, but not congruent. So that doesn't work. Okay, we did talk about, when we were talking about the bad word one here, we said there is a special condition where that does work, but it only works in a certain case, and so it doesn't work all the time, so that's why we crossed that one out. So if you look here is our special condition. Okay, you might look at this one and think angle, side, side, or side, side, angle, and think, wait, I thought that didn't work. But this is the special condition, and we give it a new name, so it's not a bad word. So if it's a right triangle, which we can see the right angles, and if there's a pair of legs congruent in each, and then if the hypotenuse is congruent for each, again, along with that right angle, which we can see here and here, then it is a way to prove triangles congruent. So we're just going to add to our list here that, right hypotenuse leg is an option, or like I said, hypotenuse leg, you'll see it sometimes. Okay, so moving on down here, in order to use the RHL theorem, the triangle must meet these 3 conditions. There has to be 2 right triangles, and we have to specifically state that in the proof. There has to be congruent hypotenuses, and we have to state that in the proof, and there has to be 1 pair of congruent legs, at least 1 pair. Okay, so if we look at this proof, and we're actually going to do it in 5 lines instead of 4, to make sure we're including everything. You can look in this one and see that there's a lot of given information here. Okay, one is that AD bisects EB. Again, that means AD is kind of like the knife cutting EB in half into 2 smaller congruent segments. It also says AB is congruent to DE. If the given information is ever not marked for you on the picture, make sure you do that. And then angle ACD and ECD and ACB are right angles, which you can see that was already put for you in the picture, but if it wasn't put there for you, you would need to make sure you include that. And we're trying to prove these 2 triangles are congruent. Given information is always already in your proof for you. So if we think about what this means right here, okay, we look at our picture. If AD bisects, if AD is like a knife cutting EB in half, what can we call point C? And hopefully you're thinking that it's a midpoint. So C is the midpoint of EB. Okay, and that is the definition of segment bisector. I'm going to shorten it so I don't run out of room. Okay, and if C is the midpoint of EB, then we have to think, what do we know from that? And hopefully you're thinking that EC is congruent to CB. And then we need to state that in our proof. And we can call that definition of midpoint. All right. And from there, if we look at our picture, we did already say that they are right angles in the picture, but we have to specifically say that they are right triangles to be able to use right hypotenuse leg. So I need to say triangle ECD and triangle BCA are right triangles. Okay, and that reason would be definition of right triangle. All right. Then last up we have is the triangle ACB is congruent to triangle DCE, which is what we were trying to prove to begin with. And that is right hypotenuse leg. Okay, again, sometimes you might just see it as hypotenuse leg. That means the same thing. All right. So now here's another proof. I would suggest you try this proof on your own, and then you can kind of check back to see if you did it right. If you want that practice on your own, I'm going to go ahead and go through it now. We can see this RT is that upside down T means perpendicular to SU. And perpendicular means that the segments are forming a right angle with each other. And it's also saying RU is congruent to RS, which it's already marked on the picture. But just again, make sure you mark it if it's not there already. From there, since it tells me those two segments are perpendicular to each other, I therefore know there's right angles there, which they did put in the picture, but I do need to specifically say that in the proof. So I can say angle RTS and angle RTU are right angles. Okay, and that is definition of perpendicular. All right, from there, we do need to specifically say that they are right triangles. So we can say triangle RUT and triangle RST are right triangles. And we can say that is definition of right triangle. Okay, from there we can look at our picture and think what else we know is congruent besides what is marked. And hopefully you're thinking this line they share. So we can say RT is congruent to RT by the reflexive property. Okay, and then last up, we're just saying the two triangles are congruent. Triangle RUT is congruent to triangle RST, and that is again by right hypotenuse leg. All right, so now using some of this to solve, on example 3, it says for what values of x or x and y are the triangles congruent by hypotenuse leg? So in this particular case, if I think about the hypotenuse, this x has to be congruent to y plus 5 if the triangles are congruent by hypotenuse leg. So I'm going to write a true equation that x is equal to y plus 5. Might think it looks weird with the x and y in the equation, but we'll figure that out in a minute. The other two legs have to also be congruent by hypotenuse leg. So I've got 2y plus 3 is equal to x plus 1. So here's the thing, is that if we have an x and y in each equation, we can solve the system of equations by the easiest way I see here is substitution. If one of the variables has to be by itself, and I can already see this x by itself, so that means I can take this y plus 5 and I can substitute it in over here into x's place. We practiced some of this substitution earlier in the year, so here we go again. So we've got 2y plus 3 is equal to, I'm putting y plus 5 in for x's place. I'm not writing x anymore, and then I'm completing the plus 1. If I go and start solving that, I've got 2y plus 3 is equal to y plus 6. If I go and subtract y from each side, I get y. If I subtract 3 from each side, I get 3. So now I figured out what y is. And if I take that and plug it in up here, then I can solve and get x is equal to 3 plus 5, which means x is equal to 8. And there we go on that part. Okay, if we look at part B, we can see, again, the hypotenuse is congruent for both. So I can set the fact that 4x plus 1 is equal to 13. I can also set the two legs congruent to each other. And I can say 2x plus y is equal to 8x minus 2y. So over here on the left, if I go ahead and solve over here, I can solve and figure out what x is. So 4x is equal to 12. And if I divide by 4 on each side, I get x is equal to 3. Over here on the right equation, you may want to go ahead and combine your x's and y's together first. Like if I go and subtract 2x from each side, I end up with 6x. If I go and add 2y to both sides, then I end up with 3y. So sometimes it's helpful just to go ahead and simplify things down a little bit. And now over here, I know that this x is equal to 3. So I can substitute it in over here. And I end up with 3y is equal to 6 times 3. And if I go ahead and solve that, I've got 3y is equal to 18. So I can solve and get y is equal to 6. All right, so there's my y, there's my x. All right, just last little bit here. On example 4, it says what additional information would prove each pair of triangles congruent by the hypotenuse-leg theorem. So if we look at A, we can see the hypotenuse is congruent for both here. We can see a pair of legs congruent. The only thing missing is that these need to be right angles. So angle A and angle Q are right angles. Okay, and if those are right angles, those are therefore right triangles. If we were doing a proof, we'd have to take it that far. All right, on B, we can see this pair of legs congruent. We can see the hypotenuse is congruent for both. So again, we just need some right angles in here. So I would need to know that B and angle D are right angles. Okay, and on C, we have the right angles this time, and we have the legs this time, but we would need to know these two hypotenuses are congruent. So we would need to know LN is congruent to XZ. Okay. And now on example 5, it says, are the following triangles congruent to each other? So we can see here that their right angles are there. We can see the leg is congruent for both. But the problem is here is this hypotenuse is 25, and this hypotenuse, I don't know what it is, but I know that it has to be something bigger than 25. If my other two sides are 7 and 25, and the hypotenuse is always the biggest side, I know it's going to be bigger than 25. So in this case, I'm going to say no, the triangles are not congruent. And in this case, the hypotenuse for each triangle is not congruent. Okay, so that's the problem there. All right, so thanks for watching section 4-6. Good luck with it, and let me know if you have any questions.